Faster than the very structure of spacetime itself, it has the power to maintain its awareness of it, and as a result, it will slowly deconstruct this idea, filling me with a sense of unease. At this moment, our night sky is rapidly changing, and within the coming decades, maybe even sooner, it could become completely unrecognizable. Experts, including deGrasse Tyson, are sounding the alarm, recognizing the inevitable changes brought on by the shifting of Polaris. The background behind this change is surprisingly unexpected. Polaris, commonly known as the North Star, has been a reliable feature in the sky for ages, serving as an essential point of reference for astronomers, navigators, and stargazers alike. However, this could soon be altered, changing the way we perceive the heavens and how we study the universe. Let's examine what this transformation might mean for us. For many years, Polaris has been a guiding light for sailors and astronomers, remaining firmly positioned in the sky. Its consistent presence has been crucial for navigation, but this stability may soon be disrupted. A paper from the respected Royal Astronomical Society, published in September 2023, raised concerns about the future of this celestial marker. Polaris is entering a turbulent phase, one where it could potentially explode, disappearing from sight forever and altering the sky as we know it. Before considering the possible outcomes of this event, let's look deeper into the characteristics of the star itself. Polaris is distinctive because of its proximity to the celestial North Pole. Positioned directly above Earth's northernmost point, it seems almost motionless in the sky. It resides in the Ursa Minor constellation, commonly known as the Little Dipper. Polaris shines with a moderate brightness, resembling a yellow-white supergiant star that is much larger and brighter than our own Sunday. However, Polaris is not just a single star, it is part of a complex triple star system consisting of Polaris A and Polaris B as a binary pair with a third star orbiting them. The gravitational forces between these stars affect their orbits and behaviors, and disruptions in their interactions could cause shifts in their brightness or pulsation patterns. Nevertheless, the precise nature of these forces is still not entirely understood. Polaris is situated about 3,223 light-years from Earth, meaning the light we currently observe from it started its journey a long time ago. If Polaris were to explode, we wouldn't see the effects for more than 300 years. It's even possible that Polaris has already exploded, but we have yet to witness it. Throughout history, the North Star has held significant cultural, navigational, and symbolic meaning. Its constant position has made it an invaluable guide for ancient sailors navigating across seas and lands. Symbolically, Polaris has represented steadfastness and direction, remaining unchanged in the ever-moving sky. For astronomers, Polaris has been a crucial reference point in the study of stellar movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have offered vital insights into the properties of stars and the behavior of variable stars. This trait has also been key in measuring cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable rhythm, making its behavior easier to forecast. Recently, however, Polaris has begun to show signs of deviating from its usual behavior. This irregularity in its pulsation cycle has intrigued astronomers, prompting further investigation into the cause of these unexpected changes. Instead of adhering to its normal pattern, Polaris has started to exhibit erratic dimming, leading to concerns that the star might be nearing the end of its life cycle. This behavior aligns with what is seen in stars approaching their final stages. The gradual increase in the pulsation period of Polaris, once steady, has been traced back to interactions within its star system. There has been a yearly increase of around 4.5 seconds in the pulsation period. While this may seem insignificant, it carries significant consequences. Some astronomers suggest that gravitational forces between the stars in the Polaris system could be driving these changes in its atmospheric conditions, directly influencing its pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between the behavior of Polaris and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have shown complex variations in brightness, raising concerns that they may be nearing a dramatic explosion. Stars at the end of their life cycles often exhibit such irregularities before their demise. NASA has expressed greater concern about Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star nears the end of its life, it undergoes several stages, including the red giant phase and ultimately a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the phase of helium exhaustion, which is common for giant stars nearing their end. These irregularities align with patterns seen in stars nearing the end of their life cycles. However, solid evidence of an impending supernova is still uncertain, and astronomers are continuing to track these anomalies to better understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a monumental event in the sky, potentially outshining the Moon and remaining visible for days, weeks, or even months. Its brilliance could drastically alter our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays a crucial role. Fortunately, Earth would likely remain safe regardless of whether Polaris explodes due to its size and distance from us. While the explosion of Polaris might not be as visually spectacular as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. This would undoubtedly draw the attention of astronomers and observatories, generating widespread interest both in the academic community and among stargazers. However, the impact on Earth's environment or ecosystems would be less significant compared to a supernova closer to our planet. First, it's important to note that while massive stars typically end their lives in a supernova explosion, this is not likely for Polaris. When a large star undergoes a supernova, its core collapses, triggering a violent shockwave that causes the star to disintegrate. However, Polaris is not massive enough to undergo such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not lead to a supernova, but will result in a quieter conclusion as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compressed core of a low to medium mass star that has used up its nuclear fuel. This remnant, although roughly the size of Earth, will still have the mass of the Sun. Once this process occurs, we will no longer observe Polaris as we know it. By comparing the effects of a potential Polaris explosion with those of actual supernova events, we can gain valuable insights into the evolution of stars and their ultimate fates. For instance, supernova events like SN 1987, ASN 2011 FA, and SN 2014 J have provided important data that help us understand what might happen to Polaris in the future. Despite detailed observations and research, space experts are still puzzled by the irregularities in Polaris's behavior. Understanding the causes behind these anomalies is crucial for advancing our knowledge of stellar evolution. The potential loss of Polaris as a celestial reference point raises fundamental questions for astronomical research, as ground-based telescopes and measurements of celestial distances would need recalibration. The mysterious behavior of Polaris highlights the need for further studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful answers to determine the star's future. The potential disappearance or transformation of Polaris could have significant ramifications not just for astronomers but also for various fields that rely on celestial navigation. Throughout history, humanity has depended on the North Star for orientation, and any major shift in its behavior would mark the end of an era in observational astronomy and navigation. If Polaris were to fade, change, or explode, the most immediate effect would be the loss of a key reference point in the night sky. For centuries, sailors, explorers, and travelers have used Polaris as a guiding star, allowing them to determine their direction without the need for compasses or modern GPS technology. Although we now have advanced tools for navigation, Polaris remains an essential astronomical marker for traditional navigation techniques. Additionally, the North Star has been deeply embedded in cultural and mythological traditions worldwide. In many societies, Polaris has symbolized constancy, guidance, and the passage of time. Ancient civilizations, including the Egyptians, Greeks, and Polynesians, incorporated Polaris into their mythology and navigation systems. Its disappearance or transformation could shift the way we connect with the stars and interpret celestial phenomena. Scientific advancements in stellar evolution. While the potential changes in Polaris may bring uncertainty, they also provide an opportunity for scientists to gain deeper insights into stellar evolution. The study of variable stars, supernova precursors, and stellar remnants is crucial for understanding the life cycles of stars. By closely monitoring Polaris, astronomers can refine their models of stellar aging, particularly in relation to Cepheid variable stars. These stars have played a key role in calibrating cosmic distances, as their brightness fluctuations allow scientists to determine distances to galaxies beyond the Milky Way. If Polaris undergoes significant changes, it could lead to a reassessment of how we measure the scale of the universe. Moreover, ongoing advancements in space-based telescopes such as the James Webb Space Telescope and upcoming next-generation observatories will enable scientists to study Polaris and similar stars in unprecedented detail. These instruments will allow researchers to analyze the chemical composition, energy output, and internal structure of Polaris, providing valuable data on the processes driving its irregular behavior.